we're looking at the Pons here. Lots of pontine nuclei. Here we see this is the cortical spinal tract here, kind of organizing, coming together to form the medullary pyramids, but it's kind of scattered throughout the Pons. Okay, now the change that's happened here, in all the previous sections, we've identified the medial lemniscus standing up, and now it's lying down. And it lies down, and it moves out laterally, and eventually we'll see it next to the spinal trigeminal tract, which is somewhere out of here, but it's not very distinct. Okay, so we get this L-shaped pathway here. The bottom part of the L is the medial lemniscus, and the part standing up is the central tegmental tract. All right, now the other thing that you can point out here is there's another nucleus coming in here, and this is the facial nucleus. And the facial nucleus gives off the facial nerve fibers, which come around and actually wrap around this nucleus up here, and that's the sixth nerve, nucleus abducens. So 6 and 7 are located right next to each other, and that's why when someone has a stroke or a mass lesion growing in the Pons, 6 and 7 tend to be involved together. Recall that when we move out, the 6 and 7 cranial nerves are very far apart. Okay, the 6th cranial nerve is here along the midline. 7th cranial nerve comes out here in the pontocerebellar angle. But in the Pons, they're right next to each other. Okay, so that's why when we have a patient with a 6th and 7th nerve palsy, we begin to think, well, the lesion is probably in the Pons itself. And then, of course, we look for perhaps some upper motor neuron findings here involved in the corticospinal tract. Recall that the hallmark of a brainstem lesion is crossed findings. So ipsilateral, in this case, let's just say we were to destroy this half of the Pons. Okay, all the cranial nerves essentially are ipsilateral. Talk to muscles on the same side. Fourth, again, is the exception, but that doesn't matter clinically. So if we destroy this area, the patient's going to have an ipsilateral 6th and 7th nerve palsy. If we destroy this area, of course, this pathway isn't crossed yet, right? So we're going to get a contralateral spastic weakness, opposite arm and leg. Okay, so that's our cross finding. Ipsilateral cranial nerve, contralateral arm and leg, either motor or sensory deficits. Okay, so again, the facial nucleus, the abducens nucleus, and then the facial nerve, which wraps around like this. All right, so we still see the middle cerebellar peduncle here, the biggest of the cerebellar peduncles, and now we see an additional cerebellar peduncle coming right in here, and that's the superior cerebellar peduncle. And recall that the great majority of this pathway is the cerebellum efferent pathway going out to the brain. Okay, and this peduncle crosses, as we'll see, there's a decussation of this pathway. Okay, there's one other thing to point out here, and there's a lot of information, but this thin little nucleus right here, this is the superior olivary nucleus. See it right next to the facial nucleus here. Superior olivary nucleus is very important for sound, for the auditory pathway, and especially for sound localization. So we get that depth, and we can appreciate when something is close to us or far away, and recall that we have some ability to adjust that, so we can try to listen to something far away or to something close.